Alright, in this video I want to review some problems about solving systems of linear equations. As for every video I make, please, if you like to, pause the video and attempt to do the problem on your own, and then unpause it to see if you got the right answer. Alright, so we're going to solve this system. So what we want to notice is that the x's, y's, equal signs, and numbers are all lined up on top of each other. So when I see that set up, I always want to use the elimination method. So elimination, we're trying to get one of the variable pairs, the x or y's, to be opposites so that when we add the equations together, their sum is 0 and effectively are eliminated. Now, it really doesn't matter which one you want to make opposite. However, sometimes one is easier than the other. So I look at this problem, I see that the y's have opposite signs and the bottom y has no number in front of it. So that is going to be my key about getting y to be eliminated. So to do that, I need to make the bottom y -3 so that it adds equals 0 with the top y, which is +3. So I have to ask myself, what do I multiply -y by to get -3? Well, it'd be +3. So I'm going to take the entire bottom equation and multiply it by 3. I'm going to rewrite the system to see my results. So, alright, so since I'm not changing the top equation, we are going to leave it be. The bottom equation, we're going to multiply everything by 3. So 4x times 3 is 12x. Negative y times 3 is -3y. And 5 times 3 is 15. Now that the y's are opposites, we're just going to add like terms together and see what we come up with. So 2x plus 12x is 14x. The y's cancel. And then 8 plus 15 is 23. And so to solve this, we're going to divide both sides by 14. So x is going to be 23 over 14. So that is a repeating decimal, so we're going to leave that alone. Once I find a value for x, I'm going to plug it into one of my original equations. I'll probably plug it into the first one. So I get 2 times x, which is 23 over 14, plus 3y equals 8. And so let's simplify this. So 2 and the 4 cancel because they're both divisible by 1. So I get 23/7 plus 3y equals 8. Now, because I'm going to move the 23 over, I want to think about 8 as a fraction over 7. So 8 is really 56 over 7. So we're going to think about it as 56 over 7. I'll subtract the 23 away. So 56 minus 23 is 33. So we get 33/7. Then I'm going to solve that by dividing by 3, which is the same thing as multiplying by a third. So these are canceled, leave me with y. Then over here, the 1, the 33, and the 3 cancel because they're both divisible by 3. So I get 11/7, and so my answer to this problem is 20.23 over 14 and 11 over 7. Okay. So let's try another one. So pause the video and give this one a shot. Okay, so in this case, the A's, B's are lined up again, and we got those B's opposite terms with one B having no number in front of it, so I'm going to eliminate again. But I'm going to do that by making the top B the opposite of the bottom one, which is 5. So I need the top B to be -5. So again, What do you multiply negative b by to get negative 5b? Well, you multiply it by 5. And so we're going to rewrite what we have. Here we go. 3 times 5 is 15, so we have 15a. Negative b times 5 is negative 5b. And 7 times 5 is 35. The bottom's going to stay the same. Okay, so we get 15a plus 2a is 17a. Those cancel because they add equals 0. And 35 plus 3 is 38. I'm going to divide both sides by 17, so I get 38 over 17. And so now I will plug this into one of the equations. The top one is always good, so I get 3 times 38 over 17 minus b equals 7. And so 3 times 38 is 114. And 114 is not divisible by 17, so I get 114 over 17 minus b equals 7. But again, I want to think about 7 as not 7, but something over 17. And so 7 is the same thing as 119 over 17. So I get 119 over 17. So I'm going to subtract that 114 over 17 away. So 119 minus 114 is 5. And then I need the b to be plus, so multiply everything by a negative 1. And b gives me negative 5 over 17. And so my answer is alphabetically A, comma, B. And there is my solution. Okay, so the next one, this case, x, y's are all lined up again, so great, except we have the y's are opposite signs, but in this case, I can't just multiply one equation to get them opposites. I got to do both. So if I'm going to get rid of y, I got to think about 2 and 3. What's the least common multiple of those numbers? Well, that would be 6. So I need to make one of the y's positive 6, one negative 6. Well, since the sign's already positive, negative, we're going to keep that. So the top I need to turn into a positive 6. So 2 times 3 is positive 6. We're going to multiply the top equation by 3. The bottom needs to be that negative 6. So what's negative 3 times y gives me negative 6? Well, that is a positive 2. So let's rewrite what we have. So here we go. Top equation. 3x times 3 is 9x. 2y times 3 is 6y. 11 times 3 is 33. The bottom, we get 2x times 2 is 4x. Negative 3y times 2 is negative 6y. And 1 times 2 is 2. So the y should cancel. 9x plus 14x is 13x. 33 plus 2 is 35. So divide by 13, I get 35 over 13. Then I plug that back in, so 3 times 35 over 13 plus 2y equals 11. So 3 times 35 is 105, but 105 is not divisible by 13, so I just get 105 over 13. And so again, I got to change the 11 to something over 13. So what is 11 times 13? Well, that is 143. So I want to think about 11 as 143 over 13. So I'll subtract 105 over 13 from that. So 143 minus 105 is 38. Now I got to divide by 2, which is the same thing as multiplying by a half. And so these will cancel, leaving me with y. And over here, the 2 and the 38 cancel because 2 goes into 38 19 times 1, so I get 19 over 13. And so my answer for this problem is 35 over 13, comma 19 over 13. Okay, fantastic. All right, so why don't you guys pause this video, see what you can do with it. Okay, so in this case, the b's are opposites, but I'll have to multiply both equations to get them to be opposite terms. But with the a's, I notice that 4 and 2 are the coefficients, and 4 is the LCM. Well, one of the terms for a already has a 4, so I just need to change one equation to get that oppositeness, which is the bottom equation. I multiply the bottom equation by -2 to make that 2a a negative 4a, and then we should eliminate those pretty easily. So here we go. I'm going to leave the top equation alone. The bottom, I'm going to get negative 4a plus 6b, and that's going to equal negative 12. So let's eliminate the a's. So I get 11b equals 6, and so b is going to be 6 over 11. So then plug these into the first equation. So I get 4a plus 5 times 6 over 11 should equal 18. Okay, so let's see, 4a, so 5 times 6 is 30. So 30 is not divisible by 11. Again, I want to think about 18 as something over 11 since we have a denominator of 11. So 18 times 11 is 198. So I'm going to subtract 30. So 198 minus 30 is 168. So 4a is equal to 168 over 11. So to solve this, I divide by 4 or multiply by the reciprocal, 1/4. So just like before, these cancel even with a. Now 168 is divisible by 4. 4 goes into it 42 times. So we get 42 over 11 as my answer. So again, A goes first alphabetically, so I list it first. And then I list B second. Okay, now we're going to transition to some word problems. Okay, so we're going to write and solve a system of linear equations to answer this question. So pause the video, work this one out, and see what you come up with. Okay, in this problem, Sarah has twice as many apples as oranges. The total number of apples and oranges is 15. How many apples and oranges does Sarah have? So in this problem, we should always define our variables because we need the variables to write a system. And so our variables should always come from what we're trying to find. That's always located in the last sentence of the description. We need to find out how many apples and oranges. So we're going to let x equal the number of apples in the problem. And then we're going to let y equal the number of oranges. It doesn't really matter what variables you use, but you probably don't want to use an O because you don't want O to be mistaken with zeros. So now based on this, let's write our descriptions here, our sentences. So first thing we know is that Sarah has twice as many apples as oranges. So her apples are twice as much. So we know that from that then that if I have oranges, I have to multiply those by 2. Sorry, not x. Let's try again. So I know if I have oranges, which are y, I have to multiply those by 2 to get the amount of apples because we have twice as many apples, right? 2 times oranges should give me the apples. And then the next sentence we have is the total number of apples and oranges is 15. So that means for us, when we take the number of apples and we add them to oranges, our total should be 15. So there's our system. So now I want to solve it. So what I want us to notice is that in this top equation here, this x is all by itself. It's actually been solved for. So that means that we can replace this 2y, what x equals, for the other x in the other equation, because in the system they have to be the same. This is the substitution method. So I'm going to plug in for the 2x in the bottom equation what x is, 2y. We're going to solve this equation, so 2y plus y is 3y. And we all know 3 times 5 is 15, so we have 5 for y. And then if we know y is 5, times that by 2 according to the first equation, it gives me x. We know x has to be 10. So I've solved my system. My last part is to answer the question, how many apples and oranges does Sarah have? So answer it in a sentence. Sarah has 10 apples and 5 oranges. And there you go. You have answered the question. The hardest part of these is always setting up the equations, but once that occurs correctly, then normally we can solve the system. You got one last problem I want to look at here. Okay, so another story problem. So pause the video and work this one out. Okay, in this problem, a total of 60 tickets were sold for a school play. Adult tickets cost $5 each, and student tickets cost $3 each. The total revenue from ticket sales was $300. How many adult and student tickets were sold? So again, our variables are going to be what we want to come up with. So X is the number of adult tickets sold. Kind of want to use the same wording as the problem description. And then Y is going to be number of student tickets sold. Okay, so what are we told about the problem? Well, we're told that, we'll highlight this, seems to be nice. So first off, we're told that there's a total of 60 tickets sold. So that means to us is that when you take the number of adult tickets sold X and you add them to the number of student tickets sold Y, that total sum should be $60. Okay, and the other piece of information we know is that adult tickets cost $5 each. Student tickets cost $3. We know that the total revenue from ticket sales for this play, was $300. So what that means is if we take the amount of money made from adult tickets, so that's 5 times every adult ticket, so it gives me total amount of money made from adult tickets. And we add that to the money made from student tickets, so we know that for every student ticket sold, we've earned $3, so 3y is the total number of money made from those ticket sales. That the sum of that should equal $300. So this is my system. So now we're going to solve it. We have options here. I tend to like to solve these ones when I have x plus y in equation by substituting. So I'm going to take this top equation. I'm just going to solve it for one of the variables. I don't care what variable it is. We'll do x this time. I'm going to solve for x by subtracting away y. So I get this new equation that y equals 60, x equals 60 minus y. So that's true. I'm going to take this 60 minus y. I'm going to substitute it right in here for the other y in the second equation. So I get 5x plus 3 times y. Whoops, let's try that again. I messed that one up. I'm not going to substitute in for the y, silly me. I'm going to substitute in for the x over here. My bad. So let's try it the correct way now. So we get 5 times x, which is 60 minus y, plus 3y should equal 300. So we need to distribute through here. So here we go. We get 5 times 60. So 5 times 60 is 300. minus y. So 5 times y is 5y plus 3y equals 300. So this is interesting. So 300s are going to cancel because they're the same thing. So we get negative 5 plus 3 is negative 2y, and I'll get 0, so y is 0. So it looks like we sold 0 student tickets here. So we're going to plug that in. So y is 0, that means x is 60. So let's just double check that. So if I take 60 in here, I'm going to double check this. Sometimes it seems hinky, so let's double check that right. So if we go 5 times 60 plus 3 times 0, that should equal 300. Well, that's 0, so that cancels. And we know 5 times 60 is 300, so that checks out. So in this problem, we know that there were only 60, and X is adult tickets, so there are only 60 adult tickets sold for the school play. So no students came to the play, only adults like parents, family members, what have you. All right, so hopefully this is something that is useful in your exploration. If you like what you saw, if you felt this was helpful, please like or subscribe to this channel. That would be great. And let me know if there's other videos for math problems that you would like to see made. All right.